let's quickly recall what we have done in the last class. We started with the chapter light. Okay. Before that, we have done some properties of waves. So light is one of the type of waves. We learned about sources of light. We have luminous and non-luminous sources of light. Luminous are the ones which can generate their own light, and non-luminous are the ones which basically reflect off light from another source, right? So the luminous source is basically light bulb or sun, and the objects which are visible to you to the naked eye are basically non-luminous. They are just reflecting off the light. And then we talked about rays and beams, a single basically arrow representing a ray. And then if you have multiple rays together, that becomes a beam. We can have parallel, converging, diverging beams together, right? We talked about the reflection of light. What is reflection of light? It is the bouncing of the light upon hitting a surface, right? And then we learned about the law of reflection that states that angle of incidence is equal to angle of reflection on a plane surface, right? We have different parts here. We have the incident ray that is hitting the surface. We have then normal, which is the 90-degree sort of line on the surface, which we draw using sort of a protractor. Then we have a ray which is bouncing off, that is labeled as R over here, that is called the reflected ray. We have two angles here, that is the angle between the incident ray and the normal is called angle of incidence. The angle between the reflected ray and the normal is called the angle of reflection, right? So in law of reflection states that angle of incident is always equals to angle of reflection, right? We have periscopes. Periscopes are basically used for looking over a obstacle, and they are aligned in such a way that they have two plane mirrors which are basically causing the angle of incidence to be 45, hence the angle of reflection is also 45. So the ray basically travels in perpendicular directions and it basically enters your eye, right? Then we have plane mirrors over here. Plane mirrors can be constructed by using a silver layer and behind the glass that basically reflects your image and forms it inside the mirror. So we have two types of images, that is real and virtual. Real images are basically produced on a screen, okay? And virtual image basically cannot be formed on a screen over here. So in plane mirror, we basically have image which are virtual because they are formed behind the screen and they have same in size basically, and basically they are erect. Erect means ke, agar let's say if you're standing up, if your face is at the top, your image will also form your face at the top, right? So just stand in front of a mirror. If you can see yourself, that is a properties of a plane mirror. It produces virtual image that is erect, straight, okay, and it is same in size. Then we learned about properties of a plane mirror. Okay, length of the distance from the object is same as the distance from the image from the mirror, right? And then we learn virtual since it is formed on the screen, and then it is same as size of the object over here, right? Then we started with the idea of refraction. What is refraction? Again, when the light ray passes through from one medium to another medium of different optical density, it basically changes the direction of wave. That is called refraction, right? So if you learned about an example over here, okay, if you have an let's say glass block here and you have surrounding air, so when it enters from low density to high density, the light ray bend towards normal. When it enters the high density to low density, the ray bend away from the normal level, right? And then we have over here an idea of refractive index. So refractive index is just a ratio of sine of angle of incidence upon sine of angle of refraction over here. Okay. And if the light rays are basically incident perpendicular to the normal, it will go undeviated without any refraction, right? We did a question over here to test your concepts. Then we talked about critical angle over here, right? So critical angle is just the angle at which the angle of the ray of the refracted ray is basically at an angle of 90 degree over here, right? That is the angle of critical. And if you exceed that particular critical angle, the ray basically is reflected inside the block. It does not go out. So that is called total internal reflection of it, right? This is what was the last class discussion here, right? So I just want to basically add on to this and move on. If you have any questions, please raise your hand. Okay, because we are speeding up. So don't stay behind. Don't be shy कि sir बोलेंगे question पूछ लिया मैंने. Feel free to ask questions. Okay, so I want to add one point here. Okay, let me just select a pen. So if you have log here, okay, you have a rectangle here, and let's say your ray is hitting this like this. Okay, it hits, go like this, and then hit like this. This is the normal here. This is the normal here, right? This is air outside, and inside you have glass block, right? And these are the angles over here: angle of incident here and the angle of reflection inside this. Let me repeat, it is I1 R1, and this is the angle of incidence inside the glass block, and this is the angle of reflection outside the glass block here, right? So you can see two things here, okay? That air is a low dense, right? Low optically dense material, because it basically produces very low hindrance in the path of the light. That is why it is low optically dense, right? And glass here is a high optically dense material here, right? So you have the formula for refractive index here, right? Which is sin A over sin R. It varies depending upon the ray. Is it entering from low density to high density or high density to low density over here, right? So वो तरह देख लें गौर से. So if you have the case one, that is the ray is basically entering low density to high density. That is the example of it is entering air to glass, right? Let's say if it is entering basically air to glass. The formula for refractive index is basically sin I over sin R, which you have seen, right? But if it is entering from high density to low density, high to low, right? Like let's say it is entering from glass to air back, right? Glass back to air. The formula changes to this sin R upon sin R, right? Just make sure कि आपको याद हो. मैं solving questions, right? This is just one thing which I wanted to add over here. Let me choose this, right? ठीक है. This is the formula which you should remember over here, right? अच्छा जी. So now let's start and let's basically simplify the expression for critical angle over here, right? So let's say you have this scenario which we have learned in the last class of critical angle, right? So let's say you have this scenario which you have here. Let me copy the diagram. Right? So let's say you basically have this scenario over here. This is your ray of incident, right? This is your incident ray, and this is your refracted ray. Okay? That is on the boundary edge of the air and glass, and it is forming an angle of 90 degrees with the normal here, right? And C is the angle of incidence for the incident ray, right? So it is again the case of what? It is entering from high density to low density, right? So the formula which we have basically formulated for this scenario is it is sin R over sin R, right? Sin of refraction angle upon sin of incidence angle, right? So over here, what is angle R? This is R, right? This is angle R over here. And this is basically angle of incidence. Okay, just put in the values. So what do you get? You get n equals to sin 90, okay, upon sin of C, right? And what is sin 90? If you recall your trigonometry chapter from my mathematics class. So if you, this is a sine graph, right? And at 90 degrees, you have a value of sine that is 1, right? This is a sine graph here, sine of x, and this is basically degrees, right? So at 90 degrees, you have a value of sine to be 1 over here. Therefore, this part becomes 1. Therefore, for critical angle, the relation of refractive index and critical angle is as follows. That is 1 over sine c, right? So you can have multiple scenario in which you have to basically use different formulas over here. So this is more simplified as compared to the last one. It is derived basically using the same relation which we have basically formalized in the last slide over here, right? Right. I hope it makes sense. If you have any questions, raise your hand. Okay. ठीक है. So this is just an example here. Let's say if you have n equals to 3 upon 2. Let me copy this. Let's say you're given a question in your exams or your test. Okay, let's say Hamza, the question is this. Okay, man, let's say your n is equals to 3 upon 2, right? Right. So I'm gonna ask you, let's say Hamza, find the critical angle, right? So you know this relation over here, refractive index and critical angle, that n is equals to 1 over sine c, right? You know n, you can find c directly. So what is n? It is 3 upon 2, okay, 1 upon sine c. Just solve for value of c. So this is going to become sine c equals to 2 upon 3. How do you remove the sine here? You basically take inverse, right? This is going to be sine inverse of 2 over 3. And if you basically calculate this using a calculator, your value of critical angle is going to come out to be, so sine inverse 2 upon 3. Your calculator should be in degree mode. So sine inverse 2 upon 3 is going to give you 41.81 degrees, right? Make sure your answer degree should be in 2 decimal places, right? That is the answer over here, and that is what is written over here, right? So your angle should be around 42 degrees. So लोगों ने round off कर दिया है. So you should stick to 2 decimal places in your exams. ठीक है? So I hope it makes sense. This is the relation. This is a basically formalized or simplified formula if you have the case for critical angle scenario. अच्छा जी. So since you know how to work it out, I'm going to give you 2 minutes to solve it out. ठीक है? Tell me, Seshu. So you want to find you are given the critical angle. You want to find the refractive index of diamond. Quickly. Once you're done, raise your hand. This is the relation of critical angle and refractive index. Okay, ji, so let's start solving it out. I hope you're almost there. You can confirm your answers while solving it out, right? So always when you start solving a question, always write down the data, what is given to you. You're given the following things. That is, you have the critical angle, that is 24 degrees, right? You want to find out what? You want to find out the refractive index of diamond, right? Let's just state the formula here, which you will use. You get 1 mark for that, right? And just put in the values to get your answer, right? So if you solve it out further, this is going to be n equals to 1 upon sine of 24 degrees. And your answer for n should be something in 3 significant figures that is required for your exams. That is 1 upon sine of 24, right? That gives the refractive index of 2.45. So 8, that is 2.46, right? 3 significant figures. If your answer is matching, give me a thumbs up quickly. Okay, so Vardha's answers are matching. Hamza's answers is matching. Okay, I believe okay, my answer is also matching. That's good. So let's continue, right? Let's continue. So now let's start just to see the multiple images in a mirror, right? Let's first of all see this. You might have a mirror that is basically not functioning properly. So let's say you put a pencil in front of a mirror. You might have observed this scenario over here. If you, let's say, go into a maze also, which is covered by the glass, you also face this scenario here, right? Have you experienced this scenario practically in your life till now? If yes, thumbs up. Multiple images in a mirror, or if your mirror is blurry, it gives you multiple images. Have you observed this scenario? Anyone, any time in your life? Okay, Mashal did. That's good. So this is happening. Why? Because there are multiple images that is getting formed inside the mirror, right? So you can see an ordinary silhouette at the back forms several images. Let's say if you have a mirror which is getting pretty old, or let's say if you buy a mirror or you made a mirror by yourself and you are not able to fix the silver properly. So you might form this scenario over here, right? So why is this blurry? Because uh, we have multiple images formed for the object over here, right? Over here, multiple reflections inside the glass. If you just see this is, let's say, the pencil stop, right? This is getting formed at multiple points. At I1, it is also forming the top of the pencil over here, and then I2, at I also it is forming the basically the image, and then I2 it is also forming another image over here. So these all basically traverse to your eye, and you basically observe the scenario over here, right? This is a damaged mirror over here. Okay, this is the scenario which happens if you have a damaged mirror. Okay. Okay, so we have totally reflecting prisms here. If you can see the periscope example, right? So if you recall the periscope example, which we learned in the last class, over there we basically used a single play set of play mirrors, okay, to create the scenario over here. Let me just show you. So yeah, it was doing what? It was reflecting the light at the angle of 45 degrees, and it was also causing the light ray to be incident at an angle of 45 degrees. So it caused the light ray to move at 90-degree angles, right? You can see that 90 degree, 90 degree. But if you have a right angle triangle prism over here like this, okay, if you have a right angled prism like this, किधर गया? Yeah. Okay, if you have a right angle prism here, so actually the critical angle for this prism is basically around 42 degrees, right? So if you basically hit a light ray, let's say if you have a light source or a light laser source over here, if you're hitting the light ray at an angle of 45 degrees, it is going to cause what? Total internal reflection, right? Total internal reflection. That is, K, you are passing the light ray, you're basically causing the light ray to be incident at an angle which is greater than critical angle, right? So 45 is greater than critical angle. So therefore, it is going to reflect all the light with an angle of 45 degrees inside the prism, right? So you can basically have reflecting prisms here, right? So you can watch experiments on YouTube, which basically reflects these scenarios here, right? So again, you can see that this is the incident ray and this is the particular normal here, and this is the reflected ray over here, which is bouncing back over here. Since the angle of incidence is greater than critical angle, the total internal reflections basically take place, and it basically reflects the light inside the glass. It does not let it go out, right? Because the angle is greater than critical angle here, right? So if you have a, this might pop in your MCQs. They might ask you which direction of the ray, which movement of the ray is correct over here. If you have a right angle prism over here, which has a critical angle, which is 42 degrees, right? So you should be sure about this scenario. You should be so have sound knowledge about टोटल टनल रिफ्लेक्शन क्यों होता है राइट. यू कैन सी के यहाँ पे इंसिडेंट रे हमारे पास आई. इफ यू मेक अ नॉर्मल हेयर, right? This would be again 45 degrees. This is again greater than critical angle here. And this again causes the ray to bounce back inside the glass. This hits the another surface over here. So again, you create a normal here. This is normal number 2, right? This is normal number 1. Again, this angle is at a degree of 45 degrees. This again causes the light to reflect back at an angle of 45 degrees. Since you know okay, this is going perpendicular to the surface, it goes straight outside, and you basically got your final reflected wave here, right? So you can basically cause change of directions using prisms if they are designed in such a way that if the critical angle is at 42 degrees, if you're passing the light ray greater than critical angle, it can cause these phenomena here, right? So this is how totally reflecting prisms are designed, and they are used in basically creating some laser patterns or so on and so forth, right? Okay. The whatever we have discussed now, we have basically it is written over here. The defects of mirrors are overcome by basically 45 right angle prisms are used. Okay. The critical angle of ordinary glass is about 42 degrees, and the ray falling, which basically are reflected off by a degree of 45 degrees. So total internal reflection takes place over here, and it can basically replace mirrors which are used in periscopes to basically create more robust, more good designs of the prism of the periscopes here, right? So they automatically creates the 90-degree patterns inside the periscope. So actually in periscopes you're using this. Okay, so if you want to create a periscope using plane mirrors for your own science DIY project, so you can also use that. Okay. Okay, so where are they used? They are used in optical fibers. So you might have heard about your internet provider, from your internet provider कि we are providing IP fiber. Okay, let's say you might have a fiber connection okay, at your house. So why do we use fiber connections? Because they are using light ray to pass on the data. Okay, so since light travels at the speed of, what is the speed of light? It is 3 exponent 8 meter per second. That is 300 million meters per second. So that's a very high speed, right? So if you use a normal copper wire, that cannot support this much speed of the transfer of data. Okay, so that is why optical fibers are replacing copper wires over here, because copper wires, this optical fiber basically works on the principle that is TIR. Okay, that is total internal reflection. So it again, when the light, when the data light Basically data is getting passed through light waves. Okay, so light travels through this particular cord, and you can see okay, the angle of incidence. If you draw normals here, तो critical angle से ज्यादा इनके पास angle होता है. ठीक है, so let's say the critical angle of the optical fiber is basically, let's say, 45 degrees. You can see it is greater than 45 degrees over here. Okay, so this angle I is right now around 55 degrees, right? So it is greater than critical angle. So the light ray basically passes on through inside this optical fiber. It does not go out. Okay, it basically let the wave transfer, and that's how data transfer takes place in optical fibers. Okay, so that's how phototunnel reflection is getting utilized in real world, right? So we are advancing, right? We are developing this technology. So whatever you're learning over here is not just theoretical, it's getting applied in real life, also, right? Also, these optical fiber pipes are also using in medicine, right? In hospitals. Okay, they're also used in hospitals. How? If you recall endoscopy. So endoscopy is a process in which they basically insert a small pipe inside the human through basically mouth or through air if they want to inspect the internal structure, internal basically veins of a human body, just to suspect or just to ensure okay, if there is no disease. So they basically send in a pipe inside the mouth, and you can see the display over here, right? So the pipe has a small camera inside this. So this is sort of a pipe. Let's say it has a small camera over here, right? So this basically goes through and this sends the data back to the computer using optical fiber that works on TIR, right? That is photo tunnel reflection. And this is the output which is basically obtained through the camera. Okay, so they are basically sending the optical light pipe through the mouth of the person, and they're basically checking the trachea, the windpipe of the person, okay, if it has any infection or not, right? So it is getting utilized everywhere in from internet to medicine to hospitals to communication and so on and so forth. Right. So if it is clear till now, give me a thumbs up. Okay, it's clear to me. Clear to Bharda, Mashal. Okay. Hamza, clear है यहाँ तक जब हमने cover किया है? Because now we'll start covering the lenses. Hamza, are you here? Okay, good. If anyone has any questions at any point of the lecture, please raise a hand or just drop in a comment, right? I have a comment here. It's good to speak up because I might miss comments. No comment पढ़ लेता हूँ. Summer paper is going on, so I was busy with it. Okay, Hamza. So just try to, I'm requesting everyone to submit by tomorrow's minute. So I can extend the deadline tomorrow, right? So just try to stick to it. आपकी इसमें एग्जाम की प्रैक्टिस भी हो रही है. अच्छा जी, so let's start. Now we're gonna start the glasses, lenses, right? Okay, we have covered the light. How do we produce light? Some phenomena in light, that is reflection, reflection. Okay. We have diffraction, which we'll cover in the end. Now we have an important topic over here that are lenses, right? So we have two types of lenses which we will cover, right? We have two types of lenses. We have converging lenses, right? And then we have diverging lenses. Okay, diverging lenses, right? And the accurate name for each of this, which is used in industry, is as follows. Converging lenses are called convex lenses. Okay, convex lenses. And the diverging lens is basically called concave lenses, right? Right? Okay. So let's first of all directly start from the diagram so that it make more sense. So the top one, which you can see, the first figure, that is a converging lens example, and then the second figure in the middle is basically example of a diverging lens example over here, right? So this one, the first one is basically converging lens, converging lens, okay, which is also called what? Convex lens, right? And the second one in your figure, that is 3.2.35b, is called the diverging lens, right? Which is also called concave lens. All right. The third one is basically the extended the extended figures. That how is light traveling through each part. Okay. So what is a converging lens? Converging lens is basically thicker from the inside. You can see it is thicker from the center, thicker from the center, and it is thinner at the edges, right? That's how you should identify it is a converging lens. Thinner at the edges. And then you have the diverging lens. How do you identify this? It is thinner at the center. It is thinner at the center, and it is thicker at the edges, right? Thicker at the edges. Okay, that's how you will identify if it is a convex or a concave lens, right? So over here you can see some points which is called C. Okay, and you can see it is almost at the center of every class, right? So what is C? C is as follows. Let me choose another color. So C over here is called the optical center, right? It is called the optical center. And what is it? Basically, it is the center point of a lens. It is the center point of a lens. Or you can say it is the point where the entire mass of the lens is compact together, right? Is found. Okay. Or the center of mass. Okay. Either way is fine. Then there are some properties over here, right? Which you see. And you can see here there are some rays which are hitting over here, right? You can see the first example over here. There are rays which are coming here, right? So this is a beam which is hitting the converging lens. And what does it do? It converges the waves. Okay. So you can see it converges to a single point, that is capital F. We will see what is this. This is called the principal focus. Right? This is called the principal focus. And every ray you can see is basically converging to this particular point. That is why it is called converging lens, because it converges the rays. Okay. They come in parallel if I draw a straight line from the center. Right? They're basically converging from the center to a single point, and hence it is called a converging lens, right? And what is small f here? This is called the focal length, right? What is focal length? Focal length is basically distance from the center to the principal focus, right? And what is principal focus? It is the point at which all the rays are converging. Okay. This is basically the points which are present over here. And what is the diverging lens? And you can see कि आपके पास capital F इधर भी है and capital F इधर भी है, right? So these are all principal focus points. Okay, ठीक है. So now let's start with the diverging lens, and you can see what is the diverging lens doing. ठीक है. Let me again draw a center line through the center of the lens, that is optical center, right? So you can see that when the rays are hitting the surface, when the ray is basically hitting the glass, it is basically diverging, right? It is moving away from the lens, so it is diverging. It is diverging. Okay, and you can notice something. Okay, so ray is the ray which is passing through the optical center is always going straight. Similarly here, and similarly here. Okay, if you just see the converging lens scenario, there was a ray which is passing through the center of the lens. It is again going straight, right? So there is some rule which you want to see, which will come in a while. So again, this is diverging all the rays over here, and hence it's called the diverging lens. Okay. So where is the image formed in a diverging lens? It is formed on the left hand side. Okay. You can see if we extend this rays virtually backwards, right? This basically focuses, this basically crosses through the principal focus that is on the left hand side, right? So this is how image is formed. Basically a set of rays are focused on a diverging lens, right? So this is the thing which we basically have to establish before starting image formation, right? And if you basically want to see कि हो कैसे रहा है, you can just see this image which is shown over here. So again, you can see कि refraction हो रहा है इसके अंदर, right? Because we have learned refraction. So it is entering from air to glass, right? And it is going to refract. Okay, so this is the normal. You can see it changes direction. It goes like this. Similarly, changes direction. Again, changes direction, right? And but if it is perpendicular to the surface, it goes straight, which we have learned in reflection, right? Similarly, here we have a certain angle with the normal. If it draws normal, there is certain angle here, right? It basically refracts and goes like this, right? So this is how the images are, the rays are basically dispersing or getting refracted if it is at a particular angle with the surface of the glass from here, right? You can apply the same scenario on the diverging lens and you're going to understand कि how is it diverging the rays coming to it, basically which are hitting it. Okay, so if let me just go back and let's just came the slide which we have just discussed. It is just dictating the thing which we have learned right now. So lenses are used in optical instruments such as cameras, spectacles, microscopes, telescopes. So they have spherical surfaces and we have two types. Okay, they have converging lens which is called a convex lens. It is thickest at the center and it basically bend lights inwards, which we have learned just now. It can be used as a magnifying glass. You should know the application also. Okay, there might be quiz. Okay, they might ask where it used or MCQ. Okay, they might have some options. They might ask you to identify the converging lens. Okay. A diverging lens is called or concave lens is thinner at the center and thicker at the edges. And it spreads the light out. It disperses the light out, and it always gives a diminished image, right? Which we can see here, right? Okay, so optical center क्या है हमारे पास? Optical center is basically the center of the lens. Is called C, and the line through C at right angles passes to the lens is called the principal axis, right? So if you basically see this, so always when you want to basically have a sort of, if you remember mathematics, हमारे पास हमेशा होता है ना xy plane होता है हमारे पास, xy plane होते हैं. Similarly, we have a reference point that is the line which is passing through the principal focus to the optical center is called the principal axis, right? Right. This is the principal axis which it is dictated in the slide that was just shown to you. Okay, it is called the principal axis. Principal axis is the line through optical center of the lens at right angles to the lens over here, right? And you can see it is at right angles to the lens. Okay, this is the right angle, right? Again, this principal axis is at right angles to with the lens. Okay. Again, we can see the applications here. Converging lens as a magnifying glass. You might have used this also in your lab or in some games, okay, or at your homes. And this is a diverging lens. You can see it diminish out the image over here. ठीक है. यहाँ पे image बड़ी हो गई. You can see if you see closely look at it, the image is basically getting magnified here. Let me choose another highlighter. Black. The image is basically getting magnified here. The image is basically getting diminished here, right? So we have magnifying and we have a diverging lens example, right? So again, we have some other points here. That is principal focus. That is the capital F, right? It basically is what? It is the following. The point on the principal axis of a lens to which light rays are parallel to the principal axis converge or basically appear to diverge, right? Again, this is the point which that is capital F where the line crosses or basically lines appear to cross in a diverging lens. It's called the principal focus here, right? It is found at both the sides of the lens, at the side of the object and at the side of the image here, right? Then we have focal length, that is small f, right? It is what? It is the length between the optical center and the principal focus of the lens. Okay, so this small f is your focal length. This small f is your focal length from the optical center to the principal focus here, right? ठीक है जी. So this is the introduction to the lenses here. Okay. So now we start forming, basically start with how do we create image diagrams. So if it is clear till now, give me a thumbs up. What types of lenses do we have? How do we basically pass array and how do we basically have, what are different points on the lens over here? If it is clear, give me a thumbs up. It's clear to Hamza. What about others? Mashal, Varda, and Maeve. It's clear to Mashal. That's good. Varda and Maeve, is it clear? If you have questions, you can ask. It's clear to Varda. That's good. Maeve, do you have some questions? Maeve, are you here or you're having some dinner? Okay, enjoying pizza over class. Okay, it's clear. Okay, that's good. If you have questions, please ask. Okay. Okay, Ji. So now we are done with the understanding lenses, the important parameters of lenses, the types of lenses, right? And now we start, since we now have a good grip over types of lenses, we start with image formation, right? how do you form image in a lens? Okay, so this is basically section which is called the image formation. Image formation. Okay. Now let me basically give you an example and then you come to the rules afterwards. Over whenever you start with the questions, you always draw two axes. Let me make it a straighter line. Now let me insert. Do you have with the optical principal axis over here? Right? This is the principal axis. Always when you create images, you have a scale, okay, with your hand. So this is the principal axis. And then you create the converging lens. Right? Let me make it more bigger. Imagine it is almost perfect. Right? This is the optical center. Just this is the optical center of the lens. Okay. You have a line which is getting drawn from here. Okay. And then let's say you have principal focus point here, right? Principal focus will be here, F. Similarly, F here at the equal distance from the right hand side. Let's say F here. And then 2F is basically twice the distance of principal focus. 2F is going to be here, and this is going to be 2F. Okay. Let's say your object is placed here, right? This is your object, right? Object O. So how can you basically create an image? So you can have, you're gonna have always at least two lines, okay? You need at least two rays to construct an image. This is very important, right? And there's some rules which we learned, kaise karte, right? So you can, the easier thing which I follow is as follows. So pehli ray to basically you're gonna have a ray which is going to hit straight, right? Perpendicularly to the center line, and it is going to cross the principal focus here, right? Right? This is a ray, and then join them together. I drew a dotted line just to make sure कि straight बने. ठीक है, you always have arrows. ठीक है, this is a ray, so it has a direction also. You have one ray, and then you basically draw another ray which passes through the optical center. So any ray which passes through optical center goes straight, right? It goes straight. So if I again join the dots to make it more neater. Okay, so this is the point. We have the image. Okay, let me put principal axis here, like I can see it clearly. This is the principal axis. And let me extend this. Yeah, and this is the point where you basically have your image. Right? And you can see, again, draw the arrow of the direction of the ray. That is very important in this scenario. You always have an arrow which is rotating the direction of the ray. Right? So here is your image which is formed here, right? So this is the method number one, right? This is method number one. Or you can say method A. You can have another approach to create the image here, which is as follows. Let me duplicate the slide. It's just slightly different than this. Okay, let's see how do we create using method B. Okay, let me go. This is method B now. I'm gonna make it B. I'm gonna erase it. Method B is basically as follows. I should not delete that line. I should delete the up one. Okay, I should delete this. So method B is as follows. Okay, you can either do method A or B. It depends upon you, but both are fine, right? Or you can have basically a line which is passing through principal focus here, and is this going to become parallel here? Okay, this is method B of forming an image, right? You get the same exact result. Okay, it doesn't matter. Okay, and you basically observe two ways here. Okay, if a ray is passing perpendicularly to the lens, okay, it will basically cross through the principal focus point, right? And then if you always basically have this ray in both the scenarios, method A, method B, right? So this is the ray which is passing through optical center. It goes without any deviations, right? So the point where they're intersecting is the point where you have the image, right? Or you can basically see this also if the ray is basically passing through principal focus on the object side. This is the object side here. Then it's going to basically go parallel to the principal axis. You can see that this line and this line is almost parallel, right? And again, the intersection point is the point where you have the image. It's going to be exactly same using both the methods. Okay. So if it is clear, if these two methods are clear, give me a thumbs up. That how do we create an image from an object? It's clear to Hamza. That's good. It's clear to Mashal. It's clear to me. And it's clear to Varda or not. It's clear to Varda. That's good, right? So you have three rules. Okay. You can have uh, sort of first ray in this sort of way, and then the second ray that is passing through optical center, or the third ray which is passing through the principal focus on the object side, right? So this is what is written over here. If a ray that is parallel to principal axis, which is refracted through the principal focus over here, right? So if a ray is passing through, basically is parallel in this side, when the principal focus is going to pass through principal focus here, right? That is what is written over there. This is the rule one. And the rule two is if the ray passes through optical center, it goes undeviated from the lens, right? If it is passing through optical center, it goes straight without deviation. Similarly here, if it is passing through optical center, it goes straight, right? And the third ray which you can create for creating diagram is basically as follows. A ray which is passing through principal focus on the object side is going to refract after the lens with parallel to with basically by staying parallel to the principal axis. You can see here if in method B, if it passes through principal focus here, it goes parallel with this principal axis here, right? Both methods are going to produce the same exact result. It's just the approach is different. You can use either approach. I would say stick to method A. It is widely used and it is simpler to basically create image using method A, right? And this is the method which your book applies also, method A, right? Acha, over with this, we can have four scenarios. Case A, case B, case C, case D. We will see what is the differing factor here. What type of image is found from case A to case D over here, right? And then we'll just move on towards the application in real life. How do we use lens in real life? And then discussion that should end your chapter, right? Okay. Let's start with case A, right? So case A is basically what? When your object, when your object is placed beyond twice of principal focus, right? Beyond 2f, right? So you can see the object is here, right? This is the object here, O. It is placed beyond 2f. Okay, so we only basically consider this like an arrow. This is the object here, right? O. So again, you can use, and this is the converging lens which we have basically created. We are just using a straight line to manipulate to basically map out a converging lens. So if you want to draw exact lens, this would look like this. Again, you have two rays which are getting utilized here. A parallel basically ray to principal axis. It should cross through the principal focus. We can see here it's getting followed in this particular scenario. And then you have a second ray which is passing directly through the center, which is going undeviated, right? And there is a point of intersection where the image is formed, that is here. Okay. This is the point where your image is formed over here. And we again show it using an arrow. This is the image formed here, right? So there are some properties which you see over here, right? Okay, if the object is placed beyond 2f, the image produced will be what? What are the properties of this? You can see here the image is flipped, right? So if the image is flipped, it is real, right? Because the real image is flipped vertically. And again, you can see it is small in size. You can compare the size also, okay? It is diminished. It is small in size, okay? And it is what? Inverted, right? And why it is real? It can be formed in a plane mirror, right? So plane mirror can have us. Not in a plane mirror. It is real basically because it is formed inside the lens over here, right? That is why it is real over here, right? And this is the property which you should learn by heart. Okay, these are asked multiple times. So let's say they might ask you to draw this scenario on a question, and then in the next part they might ask about the properties. Okay, what are the properties of this image? So you should know this, right? So then we have case B, which is that the object is placed at 2f. Object is placed at exactly twice the principal focus, that is 2f, right? So again, we follow the same rules. We draw first ray, which is parallel to the principal focus, sorry, the principal axis, and then it crosses through the principal focus point. This is one ray, which can extend this till wherever you want. You just wanted basically, you will use a pencil over here. Whenever you basically have found the intersection point, to delete the extra lines, right? And then you have the second ray, which is passing through the optical center. Again, the intersecting point is the point where you have the image, right? So this is the object. Again, if you want to use arrows to represent objects to keep it more simple, this is the object here, and this is the image here, right? Right. And again, if you want to make sure कि आपके पास लेंस सही से बना हुआ है, you can create out the map on your or the lens on your own. ठीक है. But again, you just need the central line of the lens. That is more than enough. ठीक है. And this is the principal axis. If you want to label it, that would be good. If you don't want to label it, that is also fine. Right? Principal axis. So you can see there's some properties here. Again, you can see that if you compare the O and I, the image inverted. Again, if I ask about the properties, okay, let's say Hamza, what are the properties of this image, of this case? We should map it out also. Okay, what is the first property? It is real because it is formed on the right hand side inside the basically on the right hand side of the image plane. And again, what is the another property? It is inverted. You can see objects are not, object is on this orientation and this is basically placed downwards. So it is inverted. And but the important thing here is basically it is same in size. Okay, the image and the height of the image and the height of the object is same, right? This is so depending upon these properties, we have different applications of the cases here, right? So where can you see this in real life? What is the application of this scenario? Can anyone participate and share? Okay, where do you have this scenario in real life? Yeah, you have an image formed inside a lens, which is found in real life, which forms an image that is smaller than the object. It is real and inverted. Yes. Any application in your height, in your mind? Anyone? Give me a guess. Think about scenario, think about camera, or let's say a periscope or telescope, or let's say in any hospital scenario where you can find this. Anyone? Give me a guess. It is basically using cameras. I just told you the answer. Okay, it is using camera which you have in your phones, right? Just imagine a tall building which is, let's say, 32 floors, right? You can capture it on a phone camera. You can capture it using a phone, right? Snap. So it has a basically circuitry which basically flips the image so that you are basically seeing this in your phone, right? So in camera, the image is basically formed real, inverted, and small in size because imagine capturing buildings, capturing elephant in your phone, okay? So this is one of the applications of this particular case, right? If it makes sense, thumbs up. Okay, makes sense to Maeve, makes sense to Mashal, makes sense to Hamza, Varda is left. Okay, that's good, right? So always every application has practical, every case has a practical application, right? Okay, so now case B. अब हमारे पास की प्रॉपर्टीज क्या है कि it is real, it is inverted, and it is same in size. Where can you find this in real life? What is its application? Can you think about the application? Okay, so let me leave this as a homework assignment to you. ठीक है? This is interesting and this one is interesting very. ठीक है? So इसको ज़रा ढूंढना आप. Where do you find this? ठीक है? I'm just highlighting this over here. Just find it out. This is interesting, which I want you guys to basically throw about research करें. Okay, so now we have case C over here, which is basically object placed between F and 2F, right? So this is the object. Again, you can basically draw a vector sort of diagram here. This is an arrow which is representing object, right? And again, draw two rays which is passing through the center line of the lens. And it again passes through principal focus, goes straight, and again one ray which is basically going straight through the center over here. Draw vectors, take arrows. The point of intersection is basically the point where you have the image formed, right? Achari. So this is the point where the image is formed. Now you can see that this image is inverted, okay, but it is bigger in size, right? This is the image of over here. So what are the properties of this particular scenario? What are the properties of this? Okay, it is again real. It can be projected on a screen. Okay, it is inverted, right? And it is bigger in size. Achari. What about its application? कौन सी सिनेरियो कौन सा बेसिकली इक्विपमेंट इमेज बनाता है रियल which can be projected on a screen that means you can see it ठीक है and which is bigger in size as compared to the object and it basically forms the image inverted. We have done this अभी जल्दी अभी अभी किया हमने लिटरली. So इसका real life example is basically a projector, right? A projector. So projector basically have a smaller object which is basically feed it. हम basically CD or USB लगाते हैं. It gives the set of details. It basically maps that out into a huge area onto a screen, right? And it has some circuitry which basically causes the image to be erect, but actually it is formed like this over here, right? And obviously you can see in cinemas the projector screen is very huge. It can project on the entire screen. Okay, so again, this is the lens settings which they have used to basically expand the image size over here so that it can display it to a huge area. So if case C is clear, give me a thumbs up. Okay, it's clear to me. Okay, anyone? Mashal, Varda clear है. What about Mashal and Hamza? Is this point clear? We're just closing the chapter. Hamza, are you here? Okay, good. Okay, so last case for the image formation is when an object is placed between the principal focus and the optical center. ठीक है? Now this is an interesting case here, right? Again, you can draw a vector here of the object, right? You can draw two lines here, right? पहली लाइन क्या होगी हमारे पास? First ray is going to basically be perpendicular to the center line and goes through a principal focus, right? And then the one ray which is passing through the this optical center of the lens and goes straight, right? You can observe कि ये दो rays, if it continues to move, they would never intersect, right? They would never intersect, right? So they will never intersect. So this sort of image is basically formed on the same side as of the object, right? This is basically going to be formed how? When I extend virtually the lines backwards, right? Using a scale. And there would be a point where you have an intersection, and that point will be basically the point where your image is formed, right? And this is the point where your image is formed, right? And you can see, okay, obviously you can see here there are obvious properties which you can identify from this. So if you ask about the properties of such case, you can list it down as follows. Okay, this image is virtual because it cannot be formed on screen. It is formed on the same side as of the object. Screen हमारे पास ये, ठीक है, this is screen over here, right? Or the image section over here, and you can see कि it is erect. मतलब जैसे object है वैसे ही है, it is straight, right? And this image is basically magnified. It is bigger in size, right? इसकी तो बताते हैं एप्लीकेशन क्या है रियल लाइफ में. यू हैव यूज दिस एंड आई कैन vouch on that. You have used this in your real life. इसकी एप्लीकेशन इज बेसिकली माइक्रोस्कोप, सॉरी मैग्नीफाइंग ग्लास. Can anyone explain कि how is magnifying glass doing this? Anyone? Can you explain कि how is magnifying producing this sort of image? Varda, can you guess?
Sir, I'm not sure of what I should say.
So if you just check this image, this scenario which I have placed here, it should answer the query. Sorry, the question. Magnifying glass was not here. It was in the lens section. Lens. Yeah, here it is. So you can see कि magnifying glass always get pretty close to the object, right? So जो उसका distance होगा, obviously principal focus वो बहुत दूर होगा लेंस का, but we're placing it pretty close. So this basically creates a virtual image. We can see कि the boxes जो पीछे हैं वैसे आपको दिख रहे हैं, they are not reversed. You can see the numbers also over here कि 35 is in the exact orientation जो number यहाँ पे हुई. The image is not flipping over here. It is bigger in size and it is virtual over here, right? That is the application of in real life scenario, right? I hope it makes sense now. If it makes sense, give me thumbs up quickly. Okay, good, good. I hope it makes sense. Okay, that's good. So now we have an idea of magnification. Okay, let's say if we have a magnified image, तो वो कितने रेशियो से मैग्नीफाई हुई है, ठीक है? सो इसका we have a very simple formula. Let's say this is the length of the image, right? We will use a scale. We just measure the length of this image over here. This is the DL, the length of the image, and this is basically the length of the object DO. If I want to find कि कितनी magnify हुई है, what is the magnification ratio? What is the linear magnification ratio? That is simply the length, the height of the image upon the height of the object. That is going to give you a magnification ratio over here. That is called the linear magnification ratio, right? So you might be asked, what is the linear magnification ratio of this particular scenario? So you should be able to answer this, right? So this is just the formula. Image length upon object length. That image, this is the definition of this. Linear magnification is the ratio of the image length to the object length. Okay, that's it. So I would request you guys to join for 5 more minutes because I have just 3 more slides to end. I just want to explain the real life applications. Okay, imagine, I believe there might be some people who are wearing glasses. I myself have classes for long sightedness. So I'll explain कि why do we have different type of classes and how are they designed, right, depending upon the scenarios. So we have two types of basically issues in our eyesight, that we can be short-sighted, right? We can be short-sighted or we can be long-sighted, right? Right. And the definition will be discussed soon. So a short-sighted person is a person who can see the basically closer objects clearly, but he cannot see the objects which are far away, right? You can see near objects clearly, but distant objects appear to be blurred over here, right? Because if you see this scenario, आपके पास actually जो image form, let's say if you're trying to observe an object which is pretty far away, the rays are going to enter like this. This is your retina, right? Retina screen, जहाँ पे आपके पास image form हो रही है inside your eye, ठीक है? So the image is getting formed closely, right? So you want to make sure कि image basically the intersection point should be at the retina so that it is visible enough to you, right? So you want to basically diverge these rays in such a way that they basically meet at this point, right? To fix this issue, the person who basically cannot see objects which are far away, we basically use diverging lens over here, right? So this is a concave lens, which basically which helps to fix this issue over here. This is the solution over here to this issue. It does what? It basically diverges the rays a bit so that it can meet at a particular point on the retina, and hence you basically are able to see clear distant objects, right? Along with the objects which are closer to your eyes. Okay? So this is short-sighted people over here. Then we can have another type of issue in the eye, that is long-sighted. So what is the issue in this? A long-sighted person can see distant objects clearly, but closer objects appear to be blurred here, right? So what is the issue here? Okay, let's say if we have a object which is near to your eyes, they are meeting behind the retina. Okay, this is the retina screen here. The retina is the basically sort of screen on your eye where you basically have the projection of the images here, right? So if you're long-sighted, you're not able to see the objects which are closer to you. So हो क्या रहा होता है? So when you try to object, let's say see your phone, the image getting formed behind the retina, right? Again, it's going to get blurry. So you want to do what? You want to converge the lens at a point which is again on the retina, right? So यहाँ पे you want to perform converging. That is why we use convex lens here. It basically fixes the issue over here. So it converges the lens initially so that it basically meets at the desired point on your retina, and hence you can see the objects which are closer to you along with the objects which are further away, because the image is again getting from on the retina screen over here. Right? You cannot alter the retina, okay? Because it is again by the nature cannot alter the eye. It's pretty sensitive. Not play with the eye. So you can fix it using classes which we wear. So this is how the problem is solved, and this is how the designer for the glasses works over here on the lenses. The last thing which you want to cover is dispersion of light. So you might have observed that in rain, they are rainbows, right? They are rainbows, right? And you can see different 7 colors of light. Okay. Let me just draw correctly. So we have Roy, right? R stands for red. I believe आपको याद होगा ये. And V stands for violet. ठीक है. And what happens if you basically pass a light ray, a white light, ठीक है, or a sunlight, right, which contains all the 7 colors combined together. You pass it through prism, ठीक है. It has different refractive index, right? It has a diffractive index. So it diffracts every component of light differently. Okay, so this is red, this is basically orange, this is orange. Let's just 7 colors like this. So basically they strike the screen like this. So at the top you will have red color, and at the bottom you will have word color. Okay, and what is the shortcut to remember this? It is Roy J Bev. Okay, Roy J Bev, right? So red has the highest wavelength. We will learn this in the next chapter. It has the highest wavelength, right? And it has the lowest wavelength, right? So the greater the wavelength, so the lesser the refraction, and you can see that it refracts very lesser as compared to this particular color, which is violet over here. So here that is the reason that you observe 7 colors of light after it passes through prism. Okay, you can observe these experiments on YouTube easily. They would basically dictate, show you a demonstration of how it is done. So again, it is through refraction that disperses the light into its 7 colors. And this is the beauty of physics. Okay, you can observe it in practical terms also. So when sunlight basically falls on a triangular prism, a band of colors called a spectrum is obtained. This phenomenon is called dispersion because dispersion क्या होती है? This is spreading of light. The light is spreading into 7 colors. ठीक है? It arises because white light is a mixture of many colors. The prism separates the colors because of refractive index is जो class का है हमारे पास. It bends the light of every color with different deviation, right? So red deviation is the least, the violet has the greatest deviation, and that's how you can basically separate out different colors here. So traditional colors of visible spectrum is basically in order of easy wavelength. So violet has the least wavelength and red has the greatest wavelength over here. Again, it has the least wavelength, right? And it has the highest wavelength over here, which I just labeled over there, right? And this basically marks the end of your chapter.